G'day team, welcome back to another video. So we're going to continue on expanding on our index laws, and we're going to start looking at algebraic expansion and factorization. So I've got some key expanding and factorizing rules and patterns that we're going to utilize quite a bit. So they go either way, hence the double arrow in the middle. So if we see A times by B plus C, we know that that distributes out to be A times B plus A times C. That is a given, okay? We all know that. If we have A plus B times by C plus D, then we've actually got our FOIL. So remember our FOIL, so A times C plus A times D plus B times C plus B times D. Now we've got a couple really cool identities. If we have A plus B times by A take B, that is actually called difference of two squares, and we're left with just A squared take B squared. Now, if we have A plus B all squared, that comes out to be A squared plus 2 times A times B plus B squared, and that's called a perfect square. And then this is the perfect square version when it's A take away B. It's just this sign here changes to a negative. All right, so it's going to be really important that you start learning how to spot these patterns, especially because we're going to start having variables in our indexes, all right, in our indices. So it's going to be really important that we start learning these patterns. All right, let's do a couple of expanding questions and a couple factorizing questions. So let's start with some expanding. So we've got 5 to the power negative x times by 5 to the power of 2x plus 5 times the power of x. So if we're just looking at this as a whole, 5 to the power of negative x is just one number, okay? So this looks exactly like this rule here. So we've got a number times by a number plus a number, all right? So we know this expands out like this. So let's do that now. So we've got 5 to the power of negative x times by 5 to the power of 2x plus 5 to the power of negative x plus 5 to the power of x. All right, now that we've got to this point, we've got a bunch of indices with the same base, so we can actually use our index laws. So here we've got times, so the plus we can't do anything with. That should be a times, not a plus. Otherwise, we'd be in a bit of trouble. All right, so 5 to the power of negative x times 5 to the power of 2x, we add the indices, so it's negative x plus 2x. That is 1x, so 5 to the power of x. Now, 5 to the power of negative x times by 5 to the power of x is negative x plus x, which gives me 0. So 5 to the power of 0, and we know 5 to the power of 0 gives me 1. So that actually expands out to be 5 to the power of x plus 1. Let's have a look at another example here. So a bit tricky. We've actually got rational indices. So that means fractions in our indices. So the process is exactly the same. You're now just going to be having fractions involved. So again, looks like that top one just with an extra term in here. So we've got 3 terms that x to the power of negative a half needs to be multiplied to. So we've got x to the negative a half times by 2x squared, take away x to the negative a half times by x, so I've just put that negative out the front, plus x to the negative a half plus, that should be a times 5x to the half. All right, so the 2 comes out the front because it's the only value. It's like 2 times 1. Now, x to the negative a half times by x to the x squared. So we've got negative a half plus 2, or 2 take a half, which is 3 on 2. Take away, so we've got x to the negative half times by x to the power of 1. So 1 take a half is a half, x to the power of a half. Plus 5 comes out the front, okay? Then we've got x, so negative a half to the power plus a half is 0. So we are left with 2x to the power of 3 on 2, take x to the power of a half plus 5. Okay, and that is expanded form. All right, that's expanding. Let's now have a look at factorizing. All right, so you will often see something that looks along the lines of this. Now, it is really important that you're able to identify the square numbers, so 4, 9, 16, 25, 36, 49, 64. They are super useful numbers to actually have in your brain. So saying that, 9 we know is 3 squared, so we can rewrite this as 3 squared to the power of x, and 4 we know is 2 squared, so it's 2 squared to the power of x. All right, when we have things like this, all right, we've got something to the power of something. We multiply the indices. 3 to the power of 2x, take 2 to the power of 2x. Now I'm going to do something a little bit funky here, but you'll see why in a moment. So I'm kind of going to reverse this process, but reverse the order the numbers are in. So 3 to the power of x squared means the exact same thing. Take 2 to the power of x squared. So now we have a number squared take a number squared. And if we go back up to our formula, here we have a number squared take a number squared. We can actually factorize this nice and easily to a plus b times a take b. So if we go back down to our example, this actually factorizes into 3 to the power of x, take 2 to the power of x times by 3 to the power of x plus 2 to the power of x. Okay, so see how spotting these patterns is really important. Now, what we can do, we can always jump straight from this step to this step, all right? Or if you're really clever, you can jump from this step all the way to this step, okay? However, it is really important that you understand the process. All right, let's have a look at this question. Now, this one's a bit trickier. So one thing I'm sort of spotting, I see a square number here and a square number here. We know 4 is 2 squared and we know 49 is 7 squared. So what that sort of indicates to me is we're looking at a perfect square. So we just need to check that this in here is 2 times a times b, all right? So let's find a and b first. So 4 is 2 squared, but I'm going to write that straight away as 2x squared. So using that process as before, I'm going to leave 14 2 to the power x in here, and we're going to write this as 7 squared. All right, so for perfect squares to be true, a is 2 to the power of x and b is 7. So we need to check that this middle term is equal to 2 times a times b. So we've got 2 to the power of x squared. Now 14 divided by 7 is 2. Oops, so not equals, take. So we've got 2 times by 7 times by 2 to the power of x plus 7 squared. So now we can see that we've got 2 times by b, which is our 7, times by our a, which is 2x, 2 to the power of x. So remember, multiplication doesn't matter what order it's in, but it checks out. So all we can do to factorize is put a, which is 2 to the power of x. So we've got a minus here, okay? So see this minus here? So that means our minus, and then b squared. And there we have it. We have factorized it perfectly. All right, and that's all there is to it. It is spotting patterns and using strategies to get to those patterns so we can easily factorize. All right, hopefully this helps, and we'll see you guys in the next video.